And one more thing is, the moment I run this query in the Hive, like putty console, will I be able to see the particular output anyway?
Which output?
The output what I'm getting from this in the putty.
Yeah,
Uh,
definitely. It will show you on the putty itself.
yeah, it's showing the putty. And is there any other place where we can see this generated output,
Or
like file?
okay, so you can just insert into some other table, insert into table, select a star from so and so, whatsoever you are doing. So that will insert into another table, and that output will be persisted into your SDFS as a new table.
Okay. Oh, okay.
Or someone was asking me some more exercises. Yeah, I forgot yesterday. I'll share some. So actually, I'll share them. I'll share with you today.
Okay.
Anything else anyone want to ask? No. Okay. Okay. So I know it's going a little technical now, but you have to bear a little bit because Hive and Pig are majorly used in this world to process your data, and although these are extremely, there is not much learning curve which is required to run all these things, but yeah, that might go a little bit technical, so you have to just bear with it. And Spark thing would be very much technical because that thing will be writing in a Scala. So I think you people can just try out little Scala or read out a little bit about Scala before we go on to the Spark part in next week. Okay. So we have looked at the MapReduce thing, and we saw that it was very tedious process for us to write a MapReduce code and then run the code because it'll compile the things and run the things. And if you have to write just simple things like joining up the things or group by and all those kind of things, which are highly used on your data, it's very tedious job. Moreover, the learning curve for MapReduce was pretty high. Then we looked at Hive, and you saw some issue like yesterday you ran you did a problem statement where there was a table which had around 15 to 20 columns, and you were just worried with column 1 and column I think 2 or 3 kind of thing. You just wanted order ID and then corresponding status, but for that you have to create a metadata for the whole table to read it. So you have to write unnecessary code of 20 lines or 15, basically 20 steps for each and every column to read the table. You just wanted 2 columns, but you have to write the metadata for 20 columns. So, so there are advantages, disadvantages of everything, but Pig came up from Yahoo, similar to Hive came up from Facebook, and most of the Yahoo jobs run on Pig. So it's give you similar interfaces like Hive, although it's little bit more powerful as compared to Hive in terms of unstructured data. And it can automatically predict the data types and order of data for you based on the operation which you are doing on the data. So I'll show you all these things in some time, but this guy is pretty intelligent in terms of recognizing your data. So you would have seen a lot of times we might be requiring a map, not only just the map reduce. Practically, you might be requiring a map reduce, a chains of map reduce, or joining up things, or splitting up the data, kind of thing. So these could be a normal scenarios on any kind of data, rather than just writing single map reduce code and then writing another map reduce code. That is an extremely difficult task. So all these things need to be coded in MapReduce, and that was pretty tedious job. So Facebook came up with Facebook came up with Hive, and these people came up with Pig. So both of them are now Apache license open source thing. So before going into the Pig scripting language, let me show you a few examples how easy and how powerful Pig is to process your data. And then we'll look at syntaxes of each and every operators or commands you'll be using up in Pig. So Pig is a scripting language similar to your any other scripting language. However, it's extremely powerful and there's not much great learning curve which is required up to start processing your data with the help of Pig. So let's say I have a problem statement where I want to process or I want to figure out 10 most visited pages in each category. So this is your clickstream data which might be coming from your website that contains the user ID, the URL which he or she has visited, and the time at what time he or she has visited the URL. So there's a clickstream data, very simple clickstream data which is coming from a website. And I have another static data set which contains my URL info, that is which URL belongs to which category. So CNN belongs to news, BBC belongs to news, Flickr belongs to photos, kind of thing. And the problem statement was pretty simple. I just wanted to figure out top 10 most visited pages in each category of the URLs. So I want top 10 visited pages in news. So I want top 10 visited pages in news, top 10 visited pages in photos, and so and so. So now if I have to do this thing in any damn language across the universe, I might be writing these steps. First, I'll be loading the visits page, that is this data set. Then I'll be grouping it by URL, this URL. Then for each URL, I'll generate the count. How much are the visits for this URL? And then I'll load another file, that is the URL info, and I'll figure out the URL info about that URL. And once figured out, I'll join these two data sets and then group by category, this category. And then for each category, I'll generate top 10 URLs and dump them. Right? Be it any language in the world, I would be doing these steps to figure out top 10 visited pages in each category.
Yeah, correct.
So I could have written it in Pig, I could have written that would create a MapReduce code for me, or I could have written my own MapReduce code, or I could have written in Hive kind of thing. It's up to me. So let's see if I write in Pig how I would writing the code. So we have looked at this data flow diagram. First we loaded the file, then we grouped it by URL, and then for each URL we generated a count. So the code in Pig, so don't worry about the complexity of the code. I'll explain you all these things slowly in next few slides. So first I loaded the file called visits. Then I group the visits file by URL. Then for each visit, so each of this URL, each of this statement is assigned to a variable. So for each of these visits, I generated URL and count of the visits. These are 3 steps I did over here. Then I'll load the URL info and join both of the datasets on URL. So I loaded the URL info, another file, and joined this visits counts and URL info, visits counts and URL info by URL. Then what I did over here is, then I grouped them by category, and for each category I figured out top 10. So I grouped it by category, group this thing by category, and for each category I generated top 10 and stored the out. So similar to our data, similar to the data flow diagram which I would be doing up to process the data, these are the number of steps which you have to write in Pig and your data is processed. So forget the big MapReduce code which you have to write up. You can just write that thing in 3 and 3, 6, 7, 8 lines, and everything is done for you. So don't worry about this for each, join, load, and all those kind of things. We'll be looking at each and every line in some time. So we have used some operators which are applied directly on the files like load and store over here. We have used some things like so basically we have defined the schema on top of file. Again, that is all optional, if or it's your wish if you want to define the schema on the file. Otherwise, pig will predict the schema for you. Then we use some of the user-defined functions. As I explained yesterday, you can create a user-defined functions in Hive, and those functions can be used in your program. Similarly, over here also you can just define you can define UDFs and you can use them. Or there are a lot of functions which are already there they are available with you, so you can use them. So if I have to write that guy in that program in MapReduce, this could be the complex MapReduce program which I could have written up to process that data. So you can see the simplicity, how much I can achieve with the help of Pig. Any questions? So someone was asking me that created two jobs. So at the back end, that would have created a lot of MapReduce code. Similarly over here, and this guy would create a lot of MapReduce code for you. So if we just look at this program, this will create your map and reduce code, and this would be your MapReduce life cycles which it would create up. So practically this 6 line will create 3 MapReduce code for you, and this will be the different mapper and reducer cycles which will be reading your data or joining your data, and everything would be transparent to you. You will just see 3 different application IDs spooled in your program, and the rest everything is done for you at the back end. You don't have to worry about all the complexity which is required at the back end to generate the MapReduce code. So let's look at another example before we go ahead and look at the real syntaxes of this language. But these examples will give you a little bit good feel about how powerful Pig is. So I am getting so basically I have a file where I have user data, that is user ID and his or her age kind of thing, and basically the parameters about the user. And another is I have another data set which contains the clickstream data for the user. So again, almost similar problem statement. I have to figure out top 5 most visited websites or pages by users who belong to age group of 18 to 25. So users who belong to age group of 18 to 25, I want to figure out what are the top 5 visited websites or pages which he or she is visiting up. So I have two data sets. One is user data that contains the static data about the user, here is the user ID, age, and so things. And another is the clickstream data, that is the website or URL which a user ID has visited. So if I have to do this thing, what I'll do is I have to load the user's files, filter that by the age. I'm just concerned about the users who are lying between age 18 to 25. So I'll filter this users data set by this age group, and I'll just figure out the user IDs who belong to from 18 to 25 age, and I'll load the pages data set and join them based on the user ID, group them by URL, count the clicks, and figure out top 5 clicks. So this could be a normal algorithm which I would be writing up to process this data, be in any language. So let's look at Pig. So in Pig, it will be similar thing. I'll load the data, I'll filter it, I'll load another data set, I'll join them on, sorry, I'll join them on name or user ID, whatsoever is the key, and then group by URL, count the clicks and figure out top 5 clicks. I can order them and limit the top 5 kind of thing. So at the back end, this will create you 3 jobs, that is 3 MapReduce cycles for you, and everything would be done up, everything would be transparent to you. And this is how the code would look like. So what I did is I loaded the user's data. I filtered that by age. I loaded another data set, that is a pages data set. I joined them by user ID. So user ID is name over here and user over here. Then I grouped them by URL, figured out the count of each URL, and then sorted them descending and figured out top 5 and stored the top 5 into my file system. So let me show you this data set and we'll try to run it up. Give me a minute. So you people are with me or sleeping up?
No, we are with you.
No. Okay.
With you especially. I think this looks a lot easier than MapReduce for sure.
Yeah, definitely. This is much easier, and that's the reason I told you starting up. It's not mandatory for you to understand Java, and that's the reason of everything. You have to just write code in Pig and Hive, and data would be processed up by the power of these languages. So
Yes.
So generally people now don't write MapReduce. I mean, they generally prefer going on Pig and Hive only.
yeah, I rarely write MapReduce code, and I have implemented a lot of projects, but till now, and I could have written, I would have written not more than 4 or 5 MapReduce in last 5-6 years. So I'm talking about the production scenarios. Practically, I write a lot of things to show you people, but for production scenarios, I've never not written more than 4 or 5 MapReduce codes, and I processed a lot of
Uh,
data sets.
okay. So Miraj, in the beginning when we were covering the overview, you mentioned that in very few scenarios actually you need to write MapReduce.
Hmm.
Can you give an example of such scenario where we need MapReduce
So the
and
thing
could
is,
not?
okay, so I'll tell you some explicit examples. So a problem with Hive or Pig or any of these things is they do not support things like if else or basically while loops. These are all DEG. They cannot do cyclic graphs for you. So in some scenarios, you might be looking at cyclic graphs or your data set might be something which is extremely complex to handle up. So let me give you an example. So let's say I am getting a dump from my app. So let's say I have an app, Netflix. Netflix. Okay. So when I'm getting the lockdowns from my website, from my app, Netflix, I might be getting a dump from different users, and that dump would be coming in any order. So the app is generating the logs, and that is coming to my server. So let's say it's coming like this: user ID, and then event type, and then um, few other things. let's say movie name, and then let's say time and user details. User underscore user details and movie underscore details, and then let's say um, mobile details, and network details. Like this would be this is a very common log which will be generated out of the app for each and every click or event which he or she might be doing on the app. Agree? So
Yes.
let's say a person comes and clicks on search for a movie first. So there will be event type search will be generated up with the search criteria. So at different events, different details would be coming up. So these two would be always there, but all other things might be coming up based on the event type. For search criteria might be coming up, and let's say he clicked on any movie, so click event would be coming up, and in such a scenario, movie name, movie details, network details, and other things might be coming up. And when the really movie started up, movie start would be coming up event type, and then the user details, movie details, mobile network might be coming up, and after every 2 or 3 minutes you will be generating logs or basically event from his or her device to figure out the different statistics. So whenever you are playing song or playing movie, you would be generating events at a predefined frequency from your devices so that you can figure out analytics on what users are doing on your app in such a scenario. So let's say I am getting logs. I have to generate some logs. So let me write some random data over here. So user ID, then event time. So let's say play underscore click. Then hmm, movie name. Need the time 10:50. Then user details. So again, this would be an array. Uh, ID. Let's say again one name. Mirage, age, and so and so. Then movie details, Hindi, suspense, and so and so. Network details, Airtel, 3G, Wi-Fi, off, search criteria नहीं आएगा कुछ भी. Then after that he might be clicking on play start. So he searched for a movie and then clicked on play start. Nirja 10:52, let's say. Now I can't generate a lot of data again and again from my mobile. That will be consuming a lot of data for the real user, and that would choke up the network. So now I don't want to send the user event practically. I might send a movie event, let's say, but network event each time I'll be sending up because his Wi-Fi might go up, go on again, and those kind of things. And let's say device information also was coming over here. So smartphone, and dimension is let's say 3x7. 1200 pixels kind of thing. Now I don't want to change those, send again those things. That will again increase the network data on my side. And then after a few minutes, play status and the oops. these things, and now this might not be coming, let's say, and similarly for other users, and in any order. Agreed? With me?
Yes, sir.
Yes.
Okay, so now my problem statement is I want to create user metrics, that is what user is doing, which kind of users are doing what, and the movie status is what kind of movies are played a lot, what is an average movie playtime in my system, what is what kind of smartphones are playing what kind of movies, kind of thing. So I have to do analytics on the database practically. So now if data is in this format, practically Hive and Pick cannot help me out. So in such a scenario, I might be I might have to create first session on the for the user. So I have to create session for the user first, and that session can only happen up when I group this data. And practically this thing can happen only with the help of MapReduce. Once I create a key on the user ID and group this data and figure and get all the information that is over here with all the events, then only I'll be practically able to create or use Hive and Pick for further processing. So in such a scenario, I would be writing a MapReduce code or Spark code kind of thing. So when the complexity is too high and that is not possible with Hive and Pig, and you might have to do some loops and joining up kind of thing. In such a scenario, you might be writing a MapReduce code. So I was
So
practically writing a
basically,
MapReduce
is
code
it
for this kind of thing from last 3-4 days. I was writing a Spark code for same thing which was coming up for Wing movies, and so I just gave you this example.
so using Spark that could be done, but not using Hive and Ping? Is that what you're saying?
Yeah, using MapReduce this could be done up, but not with Hive and Pig because all data is not coming in all the event first problem. And then
No,
I have
what
to
I'm
do,
asking is using Spark, Miraj.
yeah, definitely using Spark this could be done up, using MapReduce this could be done up, but with Hive and
Okay.
Pig it would be difficult because all data is not coming in all the rows.
Miraj, in other way, using Hive and Pig, you would be working on a huge volume of data within the Hadoop system. This
Yes.
data should be worked out before HDFS. So it should be more of the grouping outside HDFS and then use
No,
HDFS
your
more for
app
storage.
your app would be generating the data and that would be coming to your HDFS kind of a storage. It could be anything. And before it could be processed up for any further processing, this data has to be cleaned up, basically sanitized up. So for sanity
So
purpose, I
what,
might be using again the same HDFS guy, power of MapReduce, but writing language cannot be Hive and Pick because it would be extremely difficult for me to do that thing with Hive and Pick. Literally impossible, basically.
so can I say that before saving these particular file into HDFS within the Hadoop base, we could use Spark, which could take all this streaming data pretty quickly and do the massaging. And
La-
later, if we need Hive and Pig, we could take it for the storage purpose or retrieval purpose.
The problem with streaming is, let's say I'm considering the same data set. When a person started neither the movie, this play status event would be coming up for next 2.5 hours. Agreed. And then play pause over here, let's say. And then a play resume. And then the play resume came up. So this was, let's say, 10:52, 10:58, um, 11. So let's say these are coming at 2 minutes event. So 54, 56, then 58, and then play pause happened at, let's say, 59, and then play resume happened at 12:51. So now the problem with streaming is there's a limit to window size. So this row have came at 10:50 and the window size could be of minutes, or let's say few minutes max I can create. So for this event I'll not be figure out the parent. So for Windows streaming, I can do little massaging with the data, but practically I can't do a great massaging with the data for with any of the streaming language over here. Because when you're processing your data with any of the streaming language, you're processing your data in the Windows. So I'll be picking data for last 1 minute and processing it. So last 1 minute or 2 minute whatsoever, practically your window size would be less than a minute. Or let's say it's a minute or 2 minutes, let's say. So you will get only these two events and events for other users. You can process it, you can massage these two events, but you can't massage another events. So you can't process it prior putting into HDFS. You have to put your data into HDFS for this kind of thing, and you have to write a complex MapReduce or Spark program to process it. It's up to you, but practically Hive and Pig will not be able to help you to give loops and all those kind of thing, and creating a session ID based on the user ID and the movie and all those things, and then you can do the processing.
So, Miraj, when we come to Spark, we will be covering some of these examples, right?
I'll show you some of the examples definitely with the help of Spark, but going into such kind of example would be very difficult. But yeah, if you want to look at it, or if you have any data set which you want to play up, I can definitely help you up to write the code.
Yeah,
So,
because that is the direction we are heading towards in our company now. So I think that will really help. And another thing is,
this is the real data which was coming to me, and I was writing from last 1 week. I was just
wow.
writing
So
up.
is this okay? So is this about that Netflix has that capability of recommended for you feature? Is it the purpose of this
Yeah,
case study?
definitely.
What you are doing, right?
Recommended for you,
Okay.
and at the back end we have to do a lot of statistics, yeah, to mint the money. It's the
Mm-hmm.
UI which is visible to you is not the UI which is visible to Kavaljeet. So it's a
Yep.
lot of statistics which need to be done at the back end just for displaying the movie, costing up, and number of things.
Mm. So do you know, I mean, what Netflix actually uses for that?
So actually,
I mean, not
I know not.
important, but
I am not. Netflix have a lot of open source videos which you can look at, but
mm-hmm.
I am doing it for Wink Movies. That is a big app
Mm-hmm.
on movies from Airtel with millions of users now. So I was doing it for Wink Movies.
Cool.
Uh, okay, so where were we? Okay, so I was showing you the data. So let's say this is the data of user ID and his or her age, and nothing more than that in the file. And we looked at we loaded the user file and filtered that guy on ages, their ages. So this is a user data. We'll load this file, and then let's look at the pages file. So here the user ID, that is the name of the user, and the page which he or she has visited. It could be anything, google.com, designpathshala.com, and a number of things. So I loaded the pages and joined them. So let's try to run it up before going ahead, and that will give you a little bit feel about the things. So uh, okay, so all these code is again shared with you people. So the same program is copied over here. I'm not doing anything great, and I'm just using pig storage that will read a comma separated file. So that is again a kind of input file format which I am defining for me, and that guy will make it understand I have to read a comma separated file and I have to divide my columns on comma. So to run a pig program similar to Hive, you can go to pig console, type pig and press enter. That will take you to a pig console. That is a grunt, and grunt is nothing but the voice made by pig. Or you can run it by similar way Hive, we ran it for Hive minus f, similarly pig minus f, and give the file name. So this file, let's try to run a pig console. Another thing will run on the run with pig minus f. So I'm reading that file from that location. So see, till now it has not done any processing for me. It has just figured out some data set for me and just printing the wording. I'll show you that those things in some time. And it has just compiled up the things. So practical processing will start up when I say anything where I am storing up the data. So here I am really storing up the data. So now the processing will start up. Now the processing has started, and now you'll see it will create MapReduce code for you, creating the ZAR file. So this is the real MapReduce code which it was creating up. Now, so this is the job ID which was given for the first job. It will create few more jobs probably, and this is the URL where I can track the jobs. So it will be starting up in a minute. Processing aliases, these aliases are coming up in this job. So filtered, join, pages and users, filtered, join, pages and users, filtered, join, pages and users. So this thing came in a job, one job. Started another job. Processing aliases, grouped and summed. So another job for grouped and summed. Setting parallelism to 1. Parallelism is similar to your reducers. So setting number of reducers to 1. Now processing aliases sorted, last alias sorted. So these are all the MapReduce code which is writing at the back end. So it has written two MapReduce code, created a jar out of them, ran them. Third MapReduce code which is now running up. So you have practically created a MapReduce.
Raj,
Yeah.
if we have done any mistake and we have to kill this job, what is the best way to kill it?
Control C. Or I'll show you how not to make a mistake practically and run it without any mistake. I'll show you in a minute. So Kamalji, that asked a good question. So basically, when you are running this guy on a big fat data set, you can't just basically start storing it up and at the back end just wait for a few hours till your whole data set is not processed and then looking at the output and then figuring out, oh shit, I made a mistake, and then rerun it up, and next day your manager will be calling up what is happening with the data, or your business user might be calling up what is the output. So let it run, I'll show you. the last MapReduce code. For sorted. So stop it, just press Ctrl C and it will stop up, but let's show how not to make a mistake. So say it has created 4 MapReduce code for you at the back end and done everything for you. You don't have to write anything. It's taking a lot of time. Okay, it's done. So the output will be there. So first let's look at the output and then I'll show you. So where was the output? So I stored it at user suite dp pig output. User suite dp pig data output top 5 sites and the output is here. So top visited sites and the order they visited. Okay, and
Miraj, you are very biased in this output. Okay. I'm just kidding.
this is a sample data set. So, how not to make a mistake. So I'll open another putty. So CD. So this is the program which you ran up. So let's say I've written this program, but I want to test it up before really running on the big data set. So let's say I have just first let's look at कि मेरा joining सही हो रही है क्या? So what I can do is ILLUSTRAT illustrate joined. So this guy read some sample data from your file, read some sample data from your another file, and joined those things and printed out the output of what will be there in the join. That is sample. So it will definitely do figure out such a data which will give some output for the operator which you are joining up. So as you can see यहाँ पे इसने 3 rows उठाई थी user की क्योंकि इसको क्योंकि for 12 it was not able to figure out any output for the join. 32 it was also not able to figure out any output for the join. It picked up 3 rows intelligently. Some sample data set. So I can see my data is getting filtered on the edge. And I can see that I am joining them perfectly. The user is coming from my filtered data set also, and user ID is same coming from pages data set also. Now let's try to illustrate somewhat further. So let's see this clicks का count सही आ रहा है क्या? See. So at the backend, it has figured out again the intelligent sample data set for me. It has picked out another 3 random users, filtered them on the edge. It will always ensure that a previous data set which has been picked up is picked up in such a fashion that the next operator in your line is getting some data out of it. It will not show you empty data set. Although I have applied filter, it will intelligently figure out such data. Now I have loaded the pages. Pages is also loaded in such a fashion that is Manisha is there because Manisha was there. Joined it up. Joined में भी ये 2 लेके आया क्योंकि इसको count दिखाने थे. And printed the click counts. So this is how I can do the testing up while I'm writing the program before really running it up on my real data set.
What was the command once again?
ILLUSTRAT and the corresponding operator name.
Corresponding operator name. Sorry, what was the operator?
So these are the operators. Filtered को मैंने ये वाली command दी थी. Pages is loaded into this. Joined, grouped, summed.
Okay. And the output which you have got on the other putty, that has overall illustration of the data flow.
Yeah. Yes. So this is just illustration on your data flow on a sample data set which have been picked up from your big files.
Apurva, this is going to be very helpful for the testing purpose.
Yep, that's what I was thinking right now.
All right.
You can also, let's say you have, so this we have created a pretty big data pipeline. अभी तो मैंने 5-6 लाइनें ली हैं. Practically for big flows you might be creating 15-20 lines kind of code or even more than that. So when I come up till here, मैं तो भूल गया हूँ practically कि sorted में data type क्या है. What kind of data is there in sorted? So DSCRIB describe, let's say sorted. S capital था, small था, capital. So see, sorted has two things. One is a key of the group and another is clicks, that is of type long. So it's extremely powerful and it helps you a lot in all these things. If you, let's say, if you want to look at that, your programs are running. So again, you have touched a good thing. So I'll again show you a few other things. So let's say your program is running extremely slow. You want to look at what is the problem. You can just say expla in explain and sort it. Oops. Explain, sorted. So it has shown you the data flow pipeline, what it will pick up to run your program. So MapReduce plan, different MapReduce it will run up at the back end, and how it will load the data, it will show you all those things, and that might helpful for you when you are really writing or debugging of the things, how it's processing my data. Similar thing could have done in Hive also. There also you could have just said explain. So if let's say I'm on a Hive console rather than Grunt console, explain and your whole query, select from so and so, and that will explain you the logical flow plan of your Hive query also. In Hive also, again, if you want to do the testing, you can just select, let's say I have two big tables. So I'll select star from table 1 and what do you say? Sample. Let's say I want to just pick out 0.001%, 0.001 percent. This guy will not take it intelligently like pick takes you. Percent, join table 2, sample. Let's say this is a small table, sample 10 cent, and then run it up. So this will pick up the sample data from your these tables at so and so percentages and will show your output, and later on you can run it on real code.
So if I have to get the data for the latest data for a resource for a user, what would be the best method to retrieve that data?
Latest data, so you have to write a real query, or you might have stored it in a partition, then you would have just loaded the yesterday's partition.
No, it's not of yesterday. It is
it might be
like
anything.
A particular user or a customer have 10 different claims. What is the latest open claim? I wanted to see that.
That you have to write a real code, MapReduce code or Hive query or BigQuery only.
Okay.
Hey, Miraj, you opened this in a different screen. I mean, different putty window, right? How you got that? Because I see that is a grunt mode something.
Yeah. So how I came over here, just type pig and pressed enter. That took me to the grunt console. Similar to hive and enter, that took you to the hive console. Similarly over here, pig and type enter, that will take you to the grunt console.
Okay, grunt, right? Okay.
Yeah. So as I told you, DEC, you don't have cyclic graphs, nor if-else kind of statements or loops, mostly used for big data pipelines. So you have seen now you would have got a good feeling about how you create a data pipelines. So it's practically used for when you want to create a big data pipelines in your program, and highly used for unstructured data. Unstructured in terms of when you don't know the real structure and you just want to play up with some columns in the data kind of thing. So it will intelligently figure out the data types and n number of things for you. I'll show you all those things. So, but it's always good to define a schema on your data set, because that will help you to deal with your data in a RDBMS, similar to your RDBMS word, and that will make your programs readable. So it's a best practice to define a schema, but it's optional. So before going into deeper into this language, this is a philosophy why Yahoo called it pig. Pig can eat practically anything. So this guy, as a pig as a language, can eat any kind of a data, be it structured, be it unstructured. Pig lives anywhere. This guy also loves to live in dirty weather or at bad places, and loves to play with your bad data. Pig is a domestic animal and can be tamed up. Similarly, this guy can also be tamed up with extremely complex kind of things which you can write up in the language. And pig fly is a saying where anyone can do anything. And similarly, this guy can also process your data extremely fast. So it optimizes all the things at the backend for you, which you would not have optimized in your MapReduce code. So similar to any of the language, it also supports all of those normal data types and some complex data types like tuple, bag, and map. So tuple is nothing but a set of fields. Bag is nothing but a group of tuples, and map is a key and value pair. Any confusion? Okay. So this is how we practically write the data. We'll come to this. So let's look at the real operators which you have used till now and see the power of them. So a statement is nothing but each and every statement which you have written in a program. So see, each line is practically a statement in a program. And there could be hundreds and millions of statements. There is no limit to them. And each and every statement is normally defined to a variable. So here you can see I have defined each and every statement to a variable. So this statement is defined to filtered, this statement is assigned to pages, and so and so. And this variables you will use in the next line. There is no limit to number of statements which you want to write in your program. Schema, as I told you, schema is all optional when you are loading your data set, like we loaded over here. So we loaded the user's data set. I explicitly said name is of type char array and age is of type int, and there are 2 columns in my file. But it's all optional for me. Here I have not defined the data types. It has predicted it up for me. And I could not have defined the schema itself. So let's see the power of this guy. So I have loaded a sample data, same sample data in three different ways. So at first stage, I have explicitly defined the name as char array and age as int from the file, and I am able to do the filtering on my data set. Filter A by age not equals to 20. So by age not equals to 20, it might filter my data set where age is not equals to 20. Over here, defining age as integer, I defined age as char array. I am little lazy in figuring out the data types. I have just defined everything as char array. So everything can be defined as a char array practically, or byte array. So I have defined everything as char array. I was little lazy. But when I'm trying to do an operation, I can just say 20 as a character string, and that will again do the job for me. So till now is fine. That can be done by any language. But now comes the power of pig. So here I have not even defined how many columns are there in my file. I can just start reading them by saying $0 as the first column, $1 as second column, and so and so. So I started reading the second column by saying $1 not equals to 20, and it will do the operation for me. So till now it's cool. No, nothing great. Let's look at some more powerful stuff. So I'll show you this file before going into this complex query. So let's open this NYSE daily. Peg data NYSE daily. So this is a file which is coming as a stock data dump from one of the from NYSE stock exchange, let's say. So it has the stock stock exchange name, stock exchange ID, the stock ID, that is the stock name, the trade date when the trade happened, the open price, the closing price, the last traded value, and a number of things like that, the total traded volume, and the trade price or the closing price. Okay, so this file has 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. I'm pretty lazy. I don't want to define all the columns. And I just want to do some operation on the file. So let's say I've loaded the file. I just say load and my file name. And that loaded my file. Now I want to do some operations on the file. So for each daily, that is this operator for each daily, generate $7 divided by 1000. $7 is the 8th column. First, second, third, fourth, fifth, sixth, seventh, eighth. That is the volume, total traded volume, divided by 1000. So based on the operator, it has predicted out the data type for me for this column 7. So I am trying to divide it by 1000. So this guy intelligently thought this column is of type integer because I am doing an operation with the integer on this column. And it will just try to typecast the column 8 on an integer and will try to do the operation for me. Over here I am saying $3 into 100.0. That is something kind of double. 100.0 is double. So first, second, third, fourth column. $3 is fourth column. So it will try to typecast this column to double and it will try to multiply it with 100. The substring $0, comma something something something. So this is the first column on which I am doing some string operation. First column I am doing some string operation. So based on the operation type, it will try to typecast this to char array and will try to do the operation for me. Till now pretty good. Now I'm doing $6 minus $3. That is 7th column minus 4th column. First, second, third, fourth, fifth, sixth, 7th column minus 4th column. So now what will happen? Minus could have been implied on integer also, double also, floating point thing also. Now this guy will try to play safe. Because doubles and integers can fit in your floating points, so it will try to play safe and will try to typecast these columns to floating point and will try to output the data for me. So it will try to play safe and will try to typecast those columns to floating point and will try to do the processing for me. So let's try to run this thing and we'll try to see the output and then we'll show you the real power of pig. So okay, so this is the previous example which I showed you people. So not filtered by 20. I'm not running this. Let's try to run this dynamic on this one. Am I loading that file anywhere? I can't see. Here it is. I'm loading it here. So we'll try to load that file. So that file is loaded. Now let's try to do the same operation. So I'm doing the same operations. $7 by 1000, $3 into 100.0 substring and $6 minus $3. Now let's try to dump it. So dump is similar to store. and dump will just print the output on the UI itself rather than dumping it to into your SDFS. So dump will show you the output directly on the screen. Store will store the output into your SDFS. My PC is gone slow. तो सी लास्ट कॉलम को इसको फ्लोटिंग पॉइंट में कर लिया, ये स्ट्रिंग ले लिया इसने, इसको डबल कर दिया, इसको इंटीजर कर दिया. इंटरेस्टिंग. So it will predict out the data type for you. You don't have to do anything. Just load the file without even defining a schema of the file, and you can just start processing your data.
Miraj, it will also automatically throw an error if some wrong,
Good question.
wrong operation is kind of given.
Good question. So it will not throw any error. It will just silently convert that to null and it will start processing your data. So I'll show you that in the next slide. So let's say this is the data which I've loaded up. So this is the data which is year, the temperature which was recorded in that year, and the quality of the temperature which was recorded up. So I've loaded this file and I'm just dumping the records. So I've loaded the third column as second column is integer, and this is not an integer. So it will not throw any error. It will just silently produce the null out of it. And later on, if I have to figure out the erroneous data in my file, I can just do something like this: filter where temperature is null, and that will dump the erroneous records. Please listen to this carefully. You might be doing a lot of mistakes in this, and later on you would be calling me. So there are few things which are case sensitive over here. There are few things which are case insensitive over here. Please bear them in your mind. So the operators like load and all those kind of things which we are using till now are all case insensitive. The load in capital is equivalent to load in small. Field name. So if you have given any field name, that is you have defined a field and assigned it to basically created a variable and assigned it to some statement. So this capital A is not equivalent to a small a. So these are case sensitive, similar to your Java. And again, similarly UDF. So if you have created any UDF or if you are using any predefined UDF which is there in pick for you, that again those things are not case insensitive. So this count is not equivalent to this count. So keywords are case insensitive, but our field names and your UDFs are not case sensitive. Are case sensitive.
Miraj, you mean to say that like the path what we give the file referring to is also case sensitive?
Path like
The where the user
path?
and those particular things is
this
referring.
thing.
Yes.
So this is all your HDFS file system. HDFS file system is case sensitive.
Okay.
So this is case sensitive, but this store is again this top 5 is also case sensitive. So this top 5 is not equivalent to small t in in top 5. So that is a separate variable. And this sorted is not equivalent to small s sorted. Comment, so there are different ways you can give a comment. This is an inline comment, multi-line comment, in between the line comment. Pick functions. So we have looked at some of the functions in the previous programs. Let's try to look at them in more detail. So eval, filter, comparison, there are a lot of functions. And there are a lot of built-in functions, which are there for you in piggybank.zar. So piggybank.zar is already there in your pig files, and you can start using piggybank functions also. So there's an intensive list of piggybank functions. If you just Google piggybank, that will show you a lot of functions which are available in the piggybank zar that is already embedded with the pig program. So we looked at store. So store data into some location that will store your output of the thing. So if you have created some variable processed, so this will output the data of processed into this location. I could have stored it using pig storage something something something. So this will store my data as a comma separated. So rather than generating your data like I generated in the previous example, pig data output. So that was tab separated because that is the default separator in your Hadoop word. So if I wanted to output the data in comma separated, so I could have used the pig storage. And similarly for reading the data also. Dump is similar to your store, but this will dump the output on your UI or on your console. Similarly, I dumped it for this example. For this example, I use dump calls. Operators. So let's say I've a file which is something like this. I've stored the operator as colon separated. So I've colon separated file something like this. So I can for each is the operator which will run on for your each line in your file. For each will run for each line in your file. So for each A, that is this operator which has data something like this, generate $0, that is your column 1. $0 is Zo, Ali, E, Zo and Eve. $2, that is the third column plus 1. So third column, it will predict it is an integer type and will do the operation for you. So 2 plus 1, 3, 3 plus 1, 4 and so and so. And third column, I'm just generating some constant. So that will be generated for all your columns. So if I dump B, it will something like this. So for each is nothing but for each line in your data set. Join is to join your two operators. So let's say this is your data again, same A is your this thing, B is your this thing. So I want to join A to B using some column. So A का मैं first column use कर रहा हूँ in joining and B का मैं second column use कर रहा हूँ. So A का first column and B का second column. So this two would be joined with this two. So tie and Joe. This two would be joined with this two also. So tie and Hank. So this 3 would be joined with this 3, Het and Eve. This one don't have anything, so it is not there. This 4 has something, so this 4 will be joined with this thing, and the output is there. So we looked at the operators. So I shown you the describe thing. So describe will describe the data set कि वो किस type का है. I showed you the illustrate also. I showed you the explain also. All these commands I showed you a few minutes back. So I just shown you the for each that will run for each line in your program. So for each prices generate close minus open will generate and will basically subtract close minus open, and for each line I'll get the output in the gain. So these are some shortcuts how to write your program. So let's say I want to just figure out some columns out of my loaded data set. I can just say dot dot open. So that will take all the columns prior to open, including open. So this beginning will get these columns, what I've underlined with the red color. Open dot dot close will give all the columns to middle from open to close. So from open to close. So from open to close will come to all this data set, and volume dot dot, that is including volume, and other than that. These are the shortcuts how to write your program. Filter is to filter your data set. So filter divs by symbol don't matches. So this is the regex I gave over here. So that will filter up the things. Not will basically inverse the things. Group. Group will is similar to your group by things what you do in your Hive. That will group your data. So let's look at this guy. So filter examples I'm not running up. For each examples I'm not running up. You can try to run it at your end. So let's say I've loaded this data set. I'll show you this data set. Oh, sorry. Okay. So NYSE daily, I'll open this file. Big data NYSE daily. This is a data set which I have loaded up. So here what I've loaded up is just two columns. So when I'm reading the data set from the file, it will ignore all the other columns other than first two. It will just ignore them. Group daily by stock. So I am grouping this data set on stocks. That is the second column which I've loaded from this data. And so before that, ILLUSTRAT illustrate grouped. So see, it has picked up some temple data. So this was my daily, and this is grouped. So group will try to group your similar data based on the key. So what I did is I said group on stock. So stock pe group karo. So this will create a new data set. That data set will always have two things. One is your key on which you have grouped up, and that key will be named always as group. उस की का नाम हमेशा group आएगा. It has predicted data types also safely. Byte array, क्योंकि अभी तक मैंने कोई ऑपरेशन नहीं करा. So byte array is the safest prediction. And then it will create a bag. That is a bag of your tuples. So bag will contain all your records which are grouped together. So NYSCCIA, that will bag, and that name of that bag will be nothing but the previous operator name, that was daily. So daily was the operator name which I have grouped up. So this guy will be named daily, and this guy will always be named group. That is the key which is given to this set. Confusion, complex? Shall I repeat?
Yeah, once please, Miraj.
Okay, so I've just ran three statements. First is I've loaded this file, and I've just loaded two columns. I've loaded this file, I've just loaded these two columns. Then I grouped this file on stock. So stocks pe main group kara, and I've given this, assigned it to operator group, and I'm just trying to illustrate this group operator. So see, this is how the group operator will look like. This group operator will have two things because I've grouped it on a stock that will contain stock as a key. So group मैंने जब करा तो similar data को साथ में रखना पड़ेगा. साथ में रखने के लिए something key and value paired kind of thing has to be there. So key will contain your stock name, and value will contain your similarly grouped data. Similarly, group data is NYCCI, NYCCI. So NYCCI, NYCCI is stored in a bag, and the key is nothing but the stock name, which is the group. And the name of this thing, the key will always be group. That is the default name which will pig will give to you. And the bag which is generated of the similar data will always be named as the previous variable name. Clear? If you try to run it, that will make you make it more clear. But shall I repeat again? So practically मैंने कुछ नहीं करा, मैंने कुछ डेटा सेट को ग्रुप करा है, मैंने कुछ डेटा सेट को ग्रुप करा है. Sorry. So this is your stock, sorry, exchange, and this is your. So when I'm saying group it, when I'm saying group it on a stock, so practically this row and this row should be made together because I'm grouping it on a stock, right?
Yeah, correct.
So अब मेरे को ग्रुप करना है तो कुछ की बनानी पड़ेगी जो इस ग्रुप को एक्सेस कर सके. So key is your stock name. So CI is the key and this thing need to be together. So I've stored them as a bag. Oops. So I've stored them as a bag. NYSC comma CII and BSC comma CII. And then let's say SBI. So NYSC comma SBI and BSC comma SBI. So this is how pig will store your data. And so output is variable के दो columns हैं. One is your key and one is your value. So मेरे को इन columns को later on access भी करना है. So what is the name which is given to the key? इसको तो मैंने जब लोड करा था मैंने नेम दे दिया exchange stock है, but इनका नेम क्या है जो मेरे को इनको एक्सेस करना है इस वेरिएबल के अंदर. So the default name which pig will give to you is जिसका इस कॉलम का नाम हमेशा वो ग्रुप देगा एंड इस कॉलम का नाम हमेशा वो देगा जो कि इस डेटा सेट का नाम था. So इस डेटा सेट का नाम मैंने डेली दिया था, so इसका नाम वो डेली देगा.
Yep, got it, Miraj. Yeah.
Okay, so then I said, okay, so, अबे यार, sorry. Okay, so then I'm generating the count of day. So let's look at कि stock कितनी बार appear हो रहा है मेरे data set के अंदर. So illustrate count. So what I did over is for each group this variable, इस variable की हर line के लिए, so इस data set की हर line के लिए generate group because this is the group column name. So generate group, so stock name and count of daily, this column count of daily. So I am practically printing out कि हर stock का कितना count है मेरे data set के अंदर. So see, इसने एक ही डेटा लिया है. So CII count is 2 क्योंकि इसका count 2 था. How to access this data? This is how you can access this for each generate group, that is this variable, this column, and count of daily, that is this column. Making sense to everyone?
Yep.
Order by, similar to your order by, you can just order your data, ascending or descending. Distinct will produce a distinct output for you. Join. So you can join data sets as I showed you previously in example. So join daily. So this is one data set, divs another data set. So join daily with divs by symbol of this and by symbol of this.
But in here उसको कैसे मालूम पड़ेगा कि लेफ्ट है राइट है या
By default inner join.
Yeah,
You can
inner join.
Yeah, by default inner join, you could say, I'm just showing you. So if you want to join on two columns, symbol daily of date, symbol date of date. If you want to do left outer, you have to explicitly set left outer, right outer kind of thing, or forward outer. By default, inner join. If I have to join more than two data sets, so join A by X, B by U, C by E. So it will be joined these three data sets based on these columns.
इसमें हम लोग वो सेल्फ ज्वाइन नहीं करते हैं ना किसी में भी अपन ने लास्ट भी ऑप्शन देखा उसमें से सेल्फ ज्वाइन वगैरह का कुछ लॉजिक नहीं होगा ना
Self join you can do, join A by X and A by V or A by Y.
Oh yeah, here it can. Makes sense.
Limit is nothing similar to a limit. It will just produce 10 rows. Parallel. So parallel is similar to defining number of reducers in your program. So rather than defining set num dot reduce dot now set num dot reduce equals to 10, you can define it over here like parallel 10. So that will ensure your 10 reducers are created in your program. So now you people can guess what kind of operators would be applying on the mapper side and what kind of operators would be applied on reducer side. So this parallel is only applicable on the operators which are practically applicable on the reducer side. Because here I am just defining number of reducers. So parallel is nothing but defining the number of reducers which are required in the program to run up if you want to define them explicitly rather than pig defining them or pig and map reduce algorithm predicting for you. So you can set it explicitly. Mappers we cannot. Can we set number of mappers? Can we set number of mappers in my program? Yes, no. No answer. सारा पढ़ा लिखा है बेकार. Mapper is always defined on your input split. So based on the input split which you have there in your program, that is the number of mappers it will be created up. So practically you cannot define, technically you can define, but practically you cannot define number of mappers in your program. However, you can define number of reducers because that will ensure your number of reducers which are pulled up in your program. Or pig or bakery map reduce algorithm will be predicted based on your input data sets. So I can just define parallel 10 that will ensure the number of reducers which are created in my program is 10. And that can be applied on only those kind of variables which are applicable on the reducer side. So order, distinct, join, these are operators which will be doing their total thing or some part on the reducer side. So group and join will be doing some part on the reducer side. Order, distinct, limit will practically be running on the reducer side only. So for these kind of operators, you can define parallelism. Or on the top of the file, you can define set parallel to 10. So this will be applicable on all the operators which are running on the reducer side as parallelism 10. Any questions? Shall I run some of them? Show you the output? Okay, let me run some of them. So another way to run any pig program is pig -f and the file name, and that will run the file whatsoever is written in the file. So what I'm doing over is I'm again loading the same file nyc daily, and then I'm grouping it with parallel 10 and storing the output at this location. So if I run it, so can anyone tell me how many are the number of files which would be visible to me in this directory? So अभी डायरेक्टरी बनी नहीं होगी, अभी डिलीट हो रही है. इस डायरेक्टरी में कितनी फाइल्स दिखेंगी मुझे?
9 files.
9 files. Any
9
reason?
parallel.
I have to delete this output directory.
आपका 9 parallel करके नाम है तो.
Who creates the output file? Who writes the data to your output directory? Reducer?
Yes.
I have defined number of reducers as
9 and
10.
I mean, I assume
Parallel
this
10.
is 9 because.
Parallel 10.
Okay, parallel. Okay.
Oh, sorry. I have to. Parallel 10. So 10 files. So I'm just trying to delete a directory which is not existing. So I'll ये तो कमेंटेड ही है. एरर क्या आ रहा है मेरे पास? Hadoop fs -rm data output is direct. Oh, I don't want to delete it. Yeah. Output location valid for file. अरे हो, मैंने इनपुट एंड आउटपुट लोकेशन दोनों अलग अलग डिलीट जो मैं कर रहा था वो अलग था एंड यार. So output directory was existing अब I think मैं कुछ और डिलीट कर रहा था. So only two statements. So practically only one MapReduce code will be triggered up. And here is the tracking URL. So see, application master is triggered. Application master is the guy who manages your program in your yarn world. Each application master manages only one program which it is being created for. If you can recall the yarn slide, number of reducers 10, number of mapper 1. Mapper 1, reducer 10. So reducer 10 है इसलिए थोड़ा टाइम ले रहा है और डेटा सेट बहुत छोटा है बट reducer 10 है तो कई reducer तो कुछ काम नहीं करेंगे तो डेटा ही नहीं पहुंचा होगा. So it will practically create 10 files in this location. Data output.
Miraj, we
Yeah.
here we actually gave reducers as 10, but what I recollect last was जैसे अपन ने वो color वाला example लिया था. So there were 3 colors, so we got somewhere around 3 reducers for 3 different colors. The thing is, अभी अपन ने we gave reducer as 10, but depending on data, if it is required that there are more reducers required, then it will create extra reducers or something like that.
And that was just an illustration example. I created 3 reducers for 3 different colors. Practically that could have done on single reducer.
Okay, we could have got it on single reducer
Because
also.
each
Okay,
reducer
okay.
is handling range of hash codes and
Yes.
and n number of keys can lie in that hash code. But जब reducer
Yes.
का reduce function call होगा तो वो एक बार में एक ही key के लिए call होगा. So if reducer is handling 100 keys, the reduce function will be called 100 times.
बराबर
Here,
अपने हैशिंग वैसे चेंज करोगे आपका हैश वैल्यू वैसे मैपिंग के लिए चेंज करोगे यानी ग्रुपिंग के लिए
sorry.
आई मीन आपने फिर वो वैल्यू चेंज करोगे जैसे अपन ने रेड के लिए 100 होगा तो पहले वाला रेड्यूसर 100 से 200 के लिए दूसरा रेड्यूसर तो आप उसके जगह पे डायरेक्ट 1 to 300 या 1 to 5000 के लिए डायरेक्ट एक रेड्यूसर बना दो.
Yep. So MapReduce code will automatically create reducers for you and see 10 files 0 से 9 तक and so basically MapReduce code predict the number of reducers which are required based on the input data set and will create the number of reducers but you can define always the number of reducers. So each reducer will have some kind of data. हर reducer में कुछ range of data आएगा. And the key over here was stock, so each reducer will have some particular stock. So key A भी इसमें आया तो C A भी इसी में आएगा किसी और में नहीं आएगा. C A भी इसमें नहीं आ सकता. इसमें C R आया. So again, that's based on the hash key of these stock name. So log files are created over here only. जिस भी directory से pig -f करके चलाऊंगा तो log file यहाँ पे आती है. So for error purpose you can look at the error log files also. Sometimes you are getting the error. So if you are running it pig -f and the file name. So in such a scenario you won't be practically looking at the grunt console. So log files are created in this directory wherever you are running it up and you can look at the log files. Flatten is vice versa of your group. So if your data is something like this, that will be flattened up and each bag will become a row. So if I show you this thing, cat. So here what I did is, okay, this is an interesting file. So this is an interesting file. Before going to flatten, let's look at this file. Very complex, interesting file. Peg data baseball. So let's try to copy some lines of this file. So I've copied, I think, 2 lines. and we'll put it into some browser where I can practically see it. Yeah, 3 lines. So I've copied 3 lines from that file which I'm reading up. I'll show you how I'm reading up. So this file has baseball players data. Baseball player name, the team for he or she plays up, New York, Yankees, Auckland, and so and so. Then the places or position at which the player plays. So he plays as a catcher also and designated a hitter. And then the statistics about that player. So he played 1594 games. He in those games he made 65 hit by pitches. His base percentage is 0.79. His grand slams is 7, and so and so. So this is a key and value pair which is storing up the different statistics about the player. So each player might have different statistics. किसी में number of games ना हो सकता है किसी में किसी को grand slam ना मिले हो तो उसके लिए grand slams नहीं होंगे, and so and so. So for this the third player there is no grand slams. So I have a data which has name of the player, the team for which he plays, and then I'm storing my data in a bag which contains the position of where player plays, and then I'm containing a map key and value pair. Key and values are separated by hash over here. So I have a map where I'm storing the data about different statistics about the player. So I am reading this data. So what I did is load this file, baseball file, as name. First column name as char array, name as char array. Second column team as char array. Third column position, that is of type bag. Third position where he plays, position of type bag, position of type bag. बैग के अंदर किस टाइप के टपल्स हैं? बैग के अंदर टपल्स हैं मेरे char array टाइप के, and each tuple has only one char array, so tuple of type char arrays. And then I have a map which contains his batting score, so I've given that map as name bat and of type map, and I've loaded this file. Getting it?
Yep.
Name, team, position of type bag. Bag contains tuples, so bag contains tuples of type char array and batting average. So if I load this file into my grunt console, and if I say name as John Hubbard, team as this, position as this, and his batting map contains only one thing, games, number of games he played, nothing more than that. Now I have, let's say, so what I'm doing over here is for each, अरे यार small वाला ये मैंने ऊपर वाली लाइन भी लेनी पड़ेगी. So I'm just generating 2 rows from, I'm just taking 2 rows from that table. So I've just taken 2 rows from that big data set, and from that what I'm doing is generate name, flatten position. Generate name, flatten position as position. I'm giving that column name as position again. Illustrate position क्या नाम दिया था मैंने? Boss. cannot be cast to ORG data back. I did my mistake. Okay, not a problem. We'll write it again. So for each players generate name, flatten position as position. सही है यार, क्या problem है इसका? Think. And position was type of bag, yeah. dump dump pos. So this will take a while to run and it will flatten your data similar to this. So each row would be divided into n number of rows. It will take some time to run up. So in the meanwhile, we can just look at the further slides. UDF, so similar to Hive, you can also create your UDFs over here. You have to just extend a class and implement a function, and that will create your UDF, compile as R, and add that thing as a function name, register that jar, add that as a function name, and start using that. You can write your function in any other languages like Python and start using that. So it's not only Java, you can write your functions in any language and start using that. And there are a lot of functions which are defined in piggybank.jar. If you just look at piggybank, and there are a lot of functions already there for you for strings, date, and a number of things, you can look at them. So output आ गया. So see Ben कि हर position is divided into rows, and similarly for Joel, and so on so. So guys, I'll share a problem statement of pig for you. Any questions? Just try to do that. We are almost over with the time, so you can try it at your end later on, and then we can discuss if you are facing any problem, and then we'll start a new topic tomorrow. So, but it would be interesting if you try it out, and I'll share the data sets and the problem statement with you on your Google Drives. So any questions before we wind up? No? Okay. So I'll share in a few minutes the problem statement. Just try to go with it and just try to play around with pig. Then thanks for your time.
Okay, thanks, Miraj.
Thank you. Have a nice day. Oh, sorry. Good night.
Thank you, sir.
Thank you. Bye-bye.
Thank you. Bye-bye.